An aircraft carrier is more than a ship. It is a floating airbase, projecting power, protection, and presence across the world's oceans. With a full air wing aboard, a carrier becomes a mobile airport, able to launch and recover fighter jets anywhere on the planet.
Thousands of sailors live and work on board, operating the ship around the clock, like a floating city that never sleeps.
An aircraft carrier is longer than 3 football fields, heavier than a skyscraper planned, yet able to glide across the sea. The Gerald R. Ford is powered by advanced nuclear reactors, providing enough energy to operate for more than 20 years without refueling.
The carrier rarely sails alone. It leads an entire strike group and a powerful naval force designed for protection and control of the seas.
The Ford-class carrier introduces new technologies, faster launch systems, advanced sensors, and automation across the ship.
But before it sails the oceans, this engineering giant must first be built inside one of the most advanced shipyards on Earth.
Welcome to Newport News Shipbuilding, the only shipyard in America capable of constructing these nuclear-powered carriers.
And here, from raw steel and human skill, the USS Gerald R. Ford begins its journey from factory floor to the open ocean.
The Gerald R. Ford represents a new generation of aircraft carriers designed to be more powerful, more efficient, and more advanced than ever before. For decades, the Nimitz class ruled the seas. But the Ford class takes that legacy prowess and pushes it into the future. This ship isn't built for today alone. Its technology and systems are designed to serve for the next half-century.
Advanced automation means the Ford class can operate with fewer sailors, reducing cost while improving efficiency.
Its nuclear reactors generate almost 3 times more power than previous carriers, enough for future energy-hungry systems.
New materials, smarter layouts, and modern systems mean less maintenance and more time at sea.
From sensors to self-defense systems, this carrier is wrapped in layers of advanced technology. Every deck, every system, every corridor is designed with one purpose, to support aircraft operations flawlessly. The USS Gerald R. Ford is more than a warship. It is the flagship of a new era in naval engineering and sea power. This is Newport News Shipbuilding, the only shipyard in America capable of constructing nuclear-powered aircraft carriers.
This facility is like an industrial city, a massive ecosystem dedicated entirely to building the world's most complex ships.
Tens of thousands of skilled workers, engineers, and technicians combine their expertise here every single day. Every part of this ship is built with extreme precision, measured down to millimeters, even at massive scale.
It all begins with raw steel, specially engineered to survive the harshest oceans on Earth.
Inside the shipyard are entire factories, each one focused on building different parts of the carrier.
The constant rhythm of cutting, welding, lifting, and testing fills the air 24 hours a day.
The shipyard sits right on the coastline, so every vessel built here can roll straight into the open ocean. Long before construction begins, engineers model every room, every corridor, every system in digital detail.
And once the planning is done, the real transformation begins, as steel starts turning into a warship.
This ship begins with naval-grade steel, engineered to survive shock, pressure, and the unforgetting power of the sea. Every plate is thicker, stronger, and more resilient than ordinary steel, built for decades of non-stop service. Before a single piece is used, it is tested under extreme pressure to prove its toughness and reliability. Some steel is heat-treated, exposed to intense temperature to achieve the perfect balance of strength and flexibility.
Special coatings protect the metal from saltwater corrosion, guarding the ship from rust and decay.
These giant plates are moved like cargo, each one transported across the yard to the cutting halls.
Every sheet is measured and mapped digitally, ensuring absolute precision before fabrication begins.
Once approved, the steel is staged near cutting machines, ready to be shaped into the carrier's structure. From these raw sheets of metal,
the world's largest and most advanced warship will slowly begin to take shape.
And now, the next chapter begins, as steel enters the cutting halls to be shaped with microscopic precision. Inside these high-tech halls, raw steel begins its transformation, shaped with accuracy measured in thousandths of an inch. Computer-guided plasma and laser cutters slice through the steel to row. Clean, sharp, and incredibly precise. Every cut follows a digital blueprint. The ship is virtually assembled long before the first piece is built.
These automated machines work non-stop in Trenton wafers, cutting thousands of unique pieces day and night.
Highly skilled technicians oversee every operation, ensuring perfection at every step of the process. The finished edges are refined and smoothed, so every piece will fit flawlessly during assembly.
By the end of this phase, thousands of perfectly cut parts wait, each one destined for a specific place in the ship.
Teams of inspectors verify every measurement because even a small error can affect the entire ship.
Once approved, each piece is sent to the assembly bays, where the true structure of the carrier will begin to rise.
These giant steel frames form the backbone of the ship, the internal skeleton that gives the hull its strength and shape.
Each rib is carefully positioned and aligned, creating the curved structure that will soon become the outer hull. Laser alignment systems ensure every frame sits in exactly the right place, accurate down to millimeters. Highly skilled welders fuse the sections together, each joint carefully crafted for maximum strength.
Deck beams are installed across the frame, creating multiple internal levels within the massive hull. Piece by piece, the framework grows larger, until each segment becomes a massive standalone structure.
Every weld is inspected and tested Helmatert, because the hull must survive decades of harsh seas and shock forces.
Internal walls turn the empty frame into secure compartments, critical for safety and stability at sea. At this scale, even the workers look small, reminding us just how massive this ship will become.
Once each hull section is complete Panturu, it is transported for the next phase, where the carrier truly begins to take shape.
The next phase transforms these frames into massive modular blocks, each one the size of a building. Instead of building one ship at once, engineers construct hundreds of large sections separately. Each block contains several decks, with corridors, stairways, and structural walls already installed. Now,
Behind the outer hull lies a maze of metal, thousands of beams and plates forming the ship's inner strength.
robotic welding adds speed, while human craftsmanship ensures the finest quality at critical joints.
Many pipes and fittings are installed now, long before the blocks are joined together at the dock.
Before a block leaves the hull, it is inspected, scanned, and approved, guaranteeing long-term safety. Protective coatings are applied early, shielding the metal from corrosion and moisture. When complete, each megablock is transported across the yard, the stroof, like a moving building of solid steel.
Soon, these giant sections will be lifted into the dry dock modular, where the aircraft carrier finally begins to appear.
Each completed section is so large, it travels across the shipyard on massive multi-axle transporters.
The movement is slow and controlled, guided by engineers who monitor every inch of the derby.
Hydraulic suspension keeps the load perfectly balanced, even though each block weighs hundreds of tons.
The entire shipyard is engineered for this purpose, built to move objects as large as buildings. Safety crews escort every move, ensuring the load travels smoothly through the busy industrial environment.
These operations happen day and night. The shipyard never truly sleeps.
One by one, completed sections arrive at the dock, waiting to become part of the giant carrier. The drivers position each block with extreme precision, ready for the crane to take over. Rigging teams attach massive lifting gear, ensuring the block can be hoisted safely and securely. And now, the stage is set, 18, for one of the largest lifting operations in the world. This towering Goliath crane is the muscle of the shipyard, capable of lifting entire ship sections at once.
Before every lift, crews meticulously inspect the rigging hoist, because each section weighs hundreds of tons.
As the crane engages, the steel giant gently rises, suspended high above the shipyard floor.
To the workers below, it feels like a moving wall of steel, silently gliding through the sky.
Teams on the ground guide the lift, keeping the block stable and perfectly aligned during its journey.
Piece by piece, the sections are lowered into the dry dock, where the aircraft carrier begins to take shape. Laser alignment systems ensure that every block locks perfectly into position, with millimeter-level accuracy.
With each massive lift, the ship grows larger, its profile evolving into the unmistakable form of a carrier.
Construction here is like industrial choreography. Every crew and every machine working in harmony.
In the heart of the dry dock, the Gerald R. Ford now stands as a true giant, its massive hull almost fully complete. The final structural sections are carefully lowered into place to rig, completing the massive outer shell of the carrier.
Teams of expert welders seal every seam, fusing steel together so the hull becomes one continuous structure. Inside the hull, miles of structural beams and decks create a vast labyrinth of metal, the hidden strength of the ship.
The entire structure is measured and aligned, with tolerances so small they can barely be seen by the human eye.
Reinforcement plates strengthen key areas, ensuring the carrier can endure extreme stress at sea.
Watertight compartments are tested and verified, critical for the ship's safety and survivability.
Slowly, the once empty frame becomes a true warship, solid, complete, and ready for systems to be installed.
The dry dock operates like a colossal workshop, every crew and every machine focused on a single purpose.
And now, with the hull complete, the USS Gerald R. Ford is ready for the next stage of its transformation.